Why do we need to clean and keep water pure? A teaching and information video by Raginmund. Have you taken a shower today? Had a cup of coffee? Drunk some milk? Then you've already used clean water today. There's plenty of water on this planet, but how much of it is drinkable? Yes, but I save water, and household wastewater is always treated. I never pour dishwashing or laundry water into the garden. All right, follow me on. A journey through water. In the mist, water rises from the seas, also from meadows, fields, and forests. And yes, even from gardens if you have one and there's morning fog there. The role of water vapor in cloud formation: when water evaporates, almost exclusively pure water vapor enters the atmosphere. However, the composition of the air and the presence of particles play a crucial role in cloud formation. Here's a detailed look. 1. Pure water vapor hab molecules. The main component of evaporation is pure water vapor, as the transition from liquid to gas primarily releases pure water molecules. 2. Dissolved gas and volatile compounds. Dissolved gases. Natural water sources contain dissolved gases like oxygen O, nitrogen N, and carbon dioxide CO. These can evaporate in small amounts and be present in the atmosphere. Volatile organic compounds, VOCs, organic substances from vegetation and other natural sources, e.g. terpenes, can also transition into the gas phase and influence cloud formation. 3. Condensation nuclei. Condensation nuclei send for cloud droplets to form pure water vapor must condense onto tiny particles. These particles come from dust and mineral particles, fine mineral substances, e.g. silicates, iron oxides, from soils and desert areas, sea salt. In coastal regions, ocean waves release tiny salt crystals, mainly sodium chloride, into the air. Biological particles. This includes pollen spores and microscopic organic particles from vegetation. So in combustion residues, these originate from natural fires or human activities and also serve as condensation nuclei. Conclusion: although evaporation primarily produces pure water vapor, the dissolved gases in the environment, and more importantly, the numerous aerosol particles such as dust, sea salt, pollen, soot, and volatile organic compounds play a key role in cloud formation. Particles act as condensation nuclei, allowing water vapor to attach in the cooler atmosphere, eventually forming clouds. These processes are fundamental to the water cycle and have far-reaching impacts on weather and climate. Microplastics too? Also consider residues from paints and other substances. In principle, the pure evaporation of water leads to water vapor as individual water molecules transition into the gas phase. Solid substances and larger particles, such as microplastics or paint residues, do not evaporate directly. However, there are several mechanisms through which such substances can enter the atmosphere. Microplastics: direct evaporation process. Particles are solid materials and lack sufficient volatility to transition into the gas phase during water evaporation. Alternative mechanisms. Microplastics can still reach the air through physical processes, e.g. sea spray, wave action, aerosol formation. Once airborne, these particles can act as condensation nuclei or disperse further in the atmosphere. Residues from paints and other substances. Volatile components. Many paints and coat contain volatile organic compounds, VOCs. Under certain conditions, such as increased temperature, these substances can evaporate and enter the air, not as part of the water evaporation process, but as emissions from solvents and additives. Non-volatile components, pigments, and other non-volatile residues from paints remain in the water and do not transition into the gas phase. However, like microplastics, they can enter the atmosphere through mechanical forces, such as being carried by water droplets, aerosols. Summary: during pure water evaporation, only water molecules transition into the gas phase. Microplastics and non-volatile paint residues do not evaporate, but they can enter the atmosphere through other physical processes. Volatile components, such as VOCs from paints, can evaporate and become detectable in the air. These particles contribute to cloud formation when they act as condensation nuclei, allowing water vapor to attach to them and form droplets. These processes are complex and depend heavily on local conditions and the specific chemical properties of pollutants. What causes the formation of microplastics? Thinks about the formation of microplastics for 6 seconds. The formation of microplastics is a complex process that results from both the breakdown of larger plastic items and the intentional production of small plastic particles. Here are some key causes. 1. physical and chemical decomposition, weathering effects, UV radiation, temperature fluctuations, and mechanical stress cause larger plastic pieces to break down over time. This, known as photodegradation, makes plastics brittle, leading them to fragment into ever smaller pieces. Mechanical wear, the friction caused by wave action, water currents, or physical impacts such as transport through rivers and ocean currents, gradually reduces plastic items into smaller fragments. 2. Biological and chemical processes. Microbial action. Some microorganisms can partially degrade plastics or accelerate their breakdown, contributing to fragmentation. Chemical oxidation. The reaction of plastics with oxygen, especially in the presence of light or heat, weakens their structure, promoting further breakdown. 3. Direct release of microplastics. Microplastics in consumer products. Some cosmetics and cleaning products, exfoliating scrubs, or toothpaste intentionally contain microplastic beads. These particles enter the environment directly and do not degrade further. Abrasion from tires and textiles. Driving causes tires to shed small plastic particles, while synthetic fabrics release microscopic fibers during washing, both of which are classified as microplastics. Summary: microplastics originate from both the natural degradation of larger plastic objects and the direct introduction of tiny plastic particles from industrial and everyday sources. These particles accumulate in the environment, leading to significant long-term ecological and health concerns. Does using plastic materials in gardening contribute to microplastic pollution? Yes, using plastic films in cold frames or plastic plant pots can contribute to microplastic release. Over time, these materials degrade due to UV radiation, weather conditions, and mechanical stress, releasing small plastic fragments into the soil, water, and air. 1. Microplastic pollution from plastics in gardening. Degradation by environmental factors. Sunlight, temperature changes, and physical wear cause plastics to become brittle and break into tiny particles. Release into the environment. Microplastics can accumulate in the soil, absorbed by plants, or be washed into water sources by rain. Wind can also spread these particles. Comparison with other microplastic sources. Gardening plastics are just one contributor. Tire wear, synthetic clothing, and packaging waste also play a significant role in microplastic pollution. 2. Health risks of microplastics exposure through food, water, and air. Microplastics have been found in food, drinking water, and even the air. Long-term effects unclear. While microplastics have been detected in the human body, their long-term health effects are still under research. Scientists are investigating potential inflammatory responses and other health impacts. 3. Is recycling a solution or a problem? Extend equals linear exposure. Recycling reduces the need for new plastic production, but also extends the time plastics are exposed to environmental conditions, potentially increasing microplastic release. Example: plastics in food containers or agricultural tools. Recycled plastics in plant pots or construction materials can still break down over time, adding to environmental microplastic accumulation. Sustainable alternatives. Biodegradable plastics or materials like ceramic, wood, or metal could help reduce microplastic pollution. Conclusion: using plastic in gardening can increase microplastic pollution. While recycling helps reduce waste, it also prolongs the exposure of plastic materials to the environment, potentially leading to further microplastic release. In the long run, switching to more sustainable alternatives could help minimize environmental contamination. Key points at a glance: extended usage duration. Recycling and reuse keep plastic materials in circulation longer, reducing the need for new plastic production and minimizing waste. Long-term environmental impact: even recycled plastics remain vulnerable to natural degradation. Over time, prolonged exposure to environmental factors can lead to microplastic formation. Dependence on application. Products used indoors, such as food containers, experience less environmental stress than outdoor items like plant pots. This means the rate of microplastic release varies significantly. Circular economy and environmental management. A key approach to minimizing microplastic pollution lies in effective circular economy strategies and material management systems. Preventing plastic from entering the environment requires proper maintenance, timely replacement, and recycling at the end of its life cycle. Conclusion: recycling and reusing plastic extends its lifespan and delays the introduction of new plastic into the environment. However, it also means that these materials are exposed to degradation processes for longer, which can lead to increased microplastic growth. Over time, the key lies in a sustainable material strategy that minimizes resource consumption while ensuring responsible plastic management throughout its entire life cycle. like constantly reloading a toxin dispenser. Your analogy makes an important point. While reusing and recycling plastics extend their lifespan and reduce short-term resource consumption, they also pose the risk of slowly releasing microplastics over long periods, similar to continuously reloading the toxin dispenser. Two critical aspects to consider. One, long-term release of pollutants. Although recycling reduces immediate waste, prolonged exposure to UV radiation, mechanical wear, environmental stressors can lead to continuous release of microplastics. Two, the need for alternative approaches. To minimize long-term environmental damage, focusing solely on recycling is not enough. Developing eco-friendly alternatives and optimizing plastic management is essential to reducing cumulative pollution. Balancing the benefits of recycling against the risks of prolonged exposure remains a challenge. Long-term solutions require a combination of improved recycling methods, innovative materials, and sustainable environmental policies. Nothing stays above rain carries everything back down to earth, attaching pollutants to raindrops. This process spreads contaminants across the planet, onto mountains, fields, forests, and oceans, leading to widespread environmental pollution. This is just one way water moves across the earth. In addition to rainfall, Earth's water cycles through surface rivers and underground streams. These subterranean flows, rich in minerals, supply the natural springs from which we draw mineral water. However, these waterways no longer just carry beneficial minerals. They now transport microplastics, particles, and even large discarded debris, depending on the strength of the river, canal, or stream. On large scale, all water bodies on Earth are interconnected. Still water, which is not connected to flowing water sources, becomes polluted over time and starts to emit foul odors. Industrialized nations have done themselves no favors by exporting their waste to poorer countries. The sheer volume and concentration of pollutants make it impossible for nature to cleanse itself. The direct disposal of industrial waste into the environment and the toxic runoff from cheap disposal countries severely hinder natural purification processes. A lack of education on proper waste handling, both in industries and private households, has now backfired on global scale, and the ignorance surrounding the disposal of hazardous materials is becoming a worldwide curse as water and wind do not follow political or economic globalization strategies. Even military waste spreads across the world in this way. While landmine may not wash up on distant continent, its corroded remnants and toxic compounds do. In the case of naval mines or similar weapons, it is entirely possible for such devices to be carried to distant shores by ocean currents. The pollution of the ocean floor with household plastic waste is another clear sign of water's interconnectedness. Marine life gets entangled in this, leading to injury, disease, and death, including fish that humans rely on for food. The lack of awareness in cheap dumping countries not only fuels child labor and waste sorting, but also exposes children to toxic environments where they play and bathe in contaminated waters, resulting in new diseases and epidemics. Wild animals will perish, leaving behind toxic decay zones. Meanwhile, the health risks for domesticated animals will rise exponentially as pollution spreads. Entire agricultural fields will be poisoned by toxic rain. At a point where chronic illness has become the norm rather than the exception, the time for complacency is long past. We are sacrificing our planet. But for what? How many Earths do we think we have to spare? Are we truly building a future of prosperity and security for our children? Or are we still fighting senseless battles over power, land, and resources? Fighting for future without scarcity, even as we destroy the very environment needed to sustain life? If we do not want gods or creators and reject those with mental abilities as nonsense, evil witchcraft, or mere fairy tales, then we have no time to rest our heads on scientific warnings and reports. Saying we have time once our pockets are full is a dangerous illusion. Otherwise, in the end, it will be far more expensive and only affordable for to be paid by the wealthiest, or it will mark the end of the human species on this planet. For copyright reasons, images from scientific reports, school knowledge, and observations were recreated using the AI image generator. The photos are photos I took myself in Germany and Africa. The content is created from the same sources: general natural knowledge, my own observations, and internal research using AI.